Welcome to Pottorff's Behind the Blades, Not a Podcast. In today's episode, we'll cover what to consider when selecting a louver, aka how to avoid accidental designing a building that lightly showers indoors. I'm Stephenie Ravenscroft, and joining me is Josh Parent.
Yep. Let's start with the simple truth.
If you understand three things, louver selection gets way easier.
Yep. Selection parameters, design intent, and local building codes. If you got those three, you're not guessing, you're engineering. And most traditional louvers get evaluated on three big performance criteria: pressure drop, free area, and water penetration resistance. Think of it like this. Pressure drop is how hard does a fan have to work. Free area is how much open space do I have for airflow. And water penetration resistance is, will my louver behave like a louver or like a funnel?
Rain in the building is a bad vibe. Let's talk about rain infiltration because it sounds minor until it's not.
Right? Rain getting inside can cause everything from ruined ceiling tiles and drywall to mold growth, equipment damage, and yes, someone slipping on wet floor. Really escalates quickly. So water performance matters. AMCA 500L, which is a test standard, the test standard tells the industry how to test, encompasses several different test methods. The one we're going to focus on today is water penetration, sometimes known as still air water penetration due to the lack of blown wind during the test.
Meaning it's basically testing calm rain conditions, like sweet little gentle rain, not Texas sideways storm rain. AMCA is an association that certifies louver performance, but let's chat about what AMCA Test Standard 500L requires when it comes to the water penetration test in actual plain English.
Here's the setup. Water gets applied to the louver in two different ways. Method one, simulated raindrops falling from above the louver. Method two, water is sprayed above the louver to simulate rain running down the face of a wall. Meanwhile, air is pulled through the louver from behind, but there's no wind effect applied during the test.
So the test is basically asking, at what free area velocity does a small amount of water make it through?
Specifically, it measures free area velocity when 0.01 ounces of water per square foot of free area penetrates. And the max airflow they test and the maximum AMCA water penetration rating tops out at 1,250 feet per minute free area velocity.
So if your application involves serious wind-driven rain, just know traditional louvers may do fine in calm rain, but storm conditions are a whole different game.
Absolutely true. Let's tackle a rookie mistake. Thinking percentage free area equals better performance.
It doesn't.
Free area is more like this louver might handle larger volumes of air, but that's about it. It does not automatically mean better water rejection, lower pressure drop, or overall performance.
It's like saying a bigger doorway automatically means your house won't flood.
Exactly. Bigger opening could also mean more ways for water to sneak in, depending on blade design.
Blade design is huge. It directly impacts pressure drop and water penetration.
General rule of thumb, the more blade features you add to fight water, like steps, rain hooks, and drainage provisions, the more you tend to hurt air performance. Because airflow has to weave through a more complex path. That usually means more resistance, which means more pressure drop. And then you've got other factors that can change water performance too, like blade spacing, geometry, direction of airflow, drain pans, and rear structural supports.
So louver selection is basically balancing I need air versus I don't want water versus code says don't mess this up. So let's run down things engineers should know when selecting. Hit it, Josh.
What is the design intent? Ventilation, intake, exhaust, or architectural screening? What are the airflow requirements and acceptable pressure drop? What kind of weather exposure are we dealing with? Calm rain or wind-driven rain? What do local codes require? And lastly, and maybe most importantly, are you using free area as a sizing guide, not a this one is best trophy? And if the building is in a storm-heavy region, don't assume a traditional louver is enough just because it has decent AMCA water rating from the still air test.
All right, that's your louver starter kit. Performance criteria, what AMCA 500L actually tests, and why blade design is the secret sauce.
Next time you're selecting a louver, remember free area isn't a personality test. And calm rain performance doesn't mean you'll win a fight against sideways storm rain.
If you want to learn more, visit us at www.pottorff.com. Thanks for joining us for this episode of Behind the Blades.